Hello everyone, welcome to my YouTube channel. In this video, let's solve bubble sort. Okay, so it's bubble sort, right? So, before getting into this, I just want to tell you guys like we do have different sorting techniques, right? Sorting techniques. So, what could be the popular ones? You guys might heard this about this bubble sort and merge sort, and there is a quick sort. So, and also there is insertion sort, some, okay. Um, and also like there is like heap sort and there is bucket sort. So there are different sorting techniques, right? Why do we need this sorting techniques actually? So it's because whatever the things that we are dealing with, right? In the world of this computers, we are mostly deals with something called data, right? So and observe guys, while we are doing the DSA, right? Data structures and algorithms, we mostly focused on something called time complexity, right? Time complexity. Though there is something called space complexity, but we mostly focused on this time complexity only. In some scenarios or some problems, we used to try to optimize this by thinking like how we can be able to reduce this time, right? Though by compromising the space. Clear? There exist some scenarios, right, where even like with brute force approach, let's say with some brute force approach, if time complexity is order of n square but space is order of 1, in order to reduce this time complexity to order of n, we will try to compromise this space and increase this, right? In some problems we might observe, right? So why why this time complexity is so important is because everyone wants their application to be very fast, very quick. Because if it is slow, no one is willing to use that, right? Because every time when we see, let's say we saw a web page, okay, let's say we've opened a web page and we are seeing it's loading, that if it's loading or if it is too slow, will we be able to use it next time? No, right? We won't recommend it also. Clear? So that's why time plays a major role. So how fast the application is what matters here. So here, whatever the data that we are like focusing on, if we organize this data in such a way that we can be able to retrieve it very fast, right? Fast retrieval. So for this reason we are using this sorting techniques. So there is unorganized data, right? So if we organize this in such a way, by either by like some ascending or descending or any format, such that I can be able to get the data with a very quickest or fast time. So that's why we use this sorting techniques, and we have different sorting techniques. Not every uh, technique is feasible or optimal or efficient, okay? So out of those, one is bubble sort. Clear? Now we will understand this bubble sort. So uh, this bubble sort is for sure not an efficient one, I could say, because we do have another sorting techniques also, but we might observe that it is not efficient for sure. But this is a base, or like a basic thing and an easy thing for everyone to for us to understand, okay, to start with sorting. So that's why I start with the bubble sort, okay. So what we will do in bubble sort is like, let's take an input array. Okay, let's take an array of, let's say, like 5 1 4 2 some 8. Okay, so after sorting, what should be the output that we need to return? We need to return like 1 2 4 5 and 8, right? This is something we need to return at the end. Clear? So what we will do here is like, in the bubble sort, so we are focusing on the max value. Okay, we focusing on the max value and try to swap it with that. We first focus on the max value, and if we got the max value, then we will swap with that. Clear? So in this example, how it's going to be is like, let's say with I is equal to 0. Clear? In this instant, so what happens initially, this is our order, right? So I will compare the first index, that means index I is equal to 0 with index I is equal to 1. Okay, so I saw that 5 is greater than 1, right? So here, if array of I is greater than array of I plus 1, so in this scenario we need to swap. So what it will be, now it becomes like 1 5 4 2 8. Clear? Now again I will compare these two, so that means it's less than, right? 5 is less than 4, so that's why it's 4 5, we swap it. So 1 4 5, then 2, then 8, then again it will compare with the 2. Clear? So 1 4 5, sorry, 1 4 2 5 and 8, then again it will compare with this, but here it's less than, right? Array of I is less than array of I plus 1, so that means in the end, observe, we do have a maximum element. So in the entire array, that means this part is sorted. Clear? So we will do the same again from starting with 1 I is equal to 0, and I will compare with the I plus 1, that is like first element, and if it is less than or greater than, based on that we will either swap or just leave it like that until we sort all the elements. Clear? This is what bubble sort does. Clear? So why it is not efficient is because you are seeing, right? So for every element I need to check every time, every other element, if it is less than or if it is greater than, based on that I am going till the last element, right? So here the time complexity is equal to order of n square, and this order of n square is for average case as well as worst case scenarios. Worst case, and also, yeah, I think, so with the sortings, right, we do have considered this best case, average case and worst case scenarios. So average and worst case is order of n square, whereas best case is, that means if entire array is sorted, then it's order of n only. That means it's, this is also based on how we write the code actually. I will show at the end. Okay, so that means I will start from 1, I will go till the end, I will check if entire array is sorted, then that's it. So for if array is sorted, if array is sorted, then it's order of n only. Clear? And the space complexity is order of 1. I hope it's understand, right? So here at every instant we are checking the first two elements, then after that another two elements, after that another two elements. It will be like this, the another two elements, till I reach the last element. Clear? So now let's write the code. So here I am taking the online compiler. Okay, now so okay, how we will start? So in this scenario, let's say I will consider an integer array. which is having the values, say 5. So what are the values that we consider? 5 1 4 2 8. Okay, sorry. Okay, 5 1 4 2 8. Clear? Now I will call bubble sort. I'm passing this array. Clear? So now uh, public static void, so bubble sort, and I'm taking integer array. Clear? Now what we will do is like, let's say I will consider n for the size of array dot length gth. Okay, now I will start iterating I is equal to 0 and I less than n minus 1 and I plus plus, and for int j also I will start from 0 and j is less than n minus 1 and j plus plus. Now what I will do, so here guys I will consider n minus 1, right? Why n minus 1 is because inside what we will do, we are comparing the array of jth element with, if array of j is greater than array of j plus 1, right? So if I'm at this before this, so that means our elements will start. So here observe, so 0, how many elements that we have? So here n is equal to 5, right? So here n is equal to 5. Clear? So we pass here n is equal to 5. Now I need to consider from 0 to 4 only, right? N minus 1 means, so its value less than 4. Clear? So here n minus 1 is equal to 5 minus 1, which is 4. That means here I value I am considering 0 1 2 and 3 only. And here when you guys see j, so I started with same 0 1 2 and 3 only, because at the fourth element, which is the final element, I will consider this j plus 1, right? If I consider that n also, what I will do is like I will got like a index out of bound exception. So I don't want that, so that's why I will go till n minus 1 only. Clear? So now I consider this. If this happens, right, here array of j is greater, that means first element is greater than the next element, then what we need to do, we need to do swap, right? So that's why I will take a temporary variable array of j, and then array of j is equal to array of j plus 1, and then array of j plus 1, where I will get this value, I'll get this from temp, right? So yeah, this is it. Clear? This is the bubble sort. So let's print this system.out.println. Let's consider after sorting. After sorting, so okay, now for, let's say whatever the array that I got for int I of array, now I need to print all the values, right? System.out. Because in that array only I did all the sorting, right? So I don't change any arrays, right? I didn't took any new array. So in this array only, at every instant I'm just swapping the things. Clear? So that's the reason. And I need to print the value of I with some space. Clear? Hopefully this will work. It works, right? It's good though. But guys, think here, So what it does actually, this for loop, so this is the code, right, that everyone can write. How we can be able to optimize this is what makes it different, right? So there are two optimizations that we can do in this code. Okay, so one thing is like, let's say, so here observe, at every instant, so in the first iteration, right? So here, okay, we will go to whiteboard. So here, so guys, in the first iteration, so I saw, for I is equal to 0, I saw the last element is sorted, right? And for I is equal to 1, I saw that the last two elements are sorted, right? And for increment in the I saw that those many elements at the last are sorted, right? But here in the code, okay, sorry, here in the code we are saying that, what we are saying, so every time j goes till n minus 1, though I know that last elements are sorted, but still it goes till n minus 1, right? So for this we can be able to optimize by subtracting it with I. So I also incrementing, right? So how many number of elements that we sort is based on I, right, actually. So that's why I'm subtracting that with I value to uh, go till that particular element only. So here, so in the I is equal to 0, I sort one element, I is equal to 1, I sort second element, right? So that's why I'm using this till here, and I add the condition less than at this particular value. That means it will go till here, right? So that's why I added this. This is one optimization I could say. And the second optimization is, guys, I told one thing right here. So in the best scenario, if array is sorted, so it's order of n only, complexity, right? It's order of n. But here observe, does it is order of n? No, right? Nowhere we are checking that that particular element is sorted, right? So every time it will go here, it will go first element, it will check the second, then third, then fourth. Every time the process is continued similar, seamlessly, right? But is it needed? No, right? The array is already sorted. So if I search, like if I see the first n elements, in at first time only, if I find that this particular array is sorted, then that has order of n time complexity. Clear? So for this value, we can do a simple addition to this thing is, how about if I add something like a tracking part, like a, so let's say I will consider a boolean called swap. Okay, initially it is false. Okay, now here is what the swapping is happening, right? So if swap happens, so swap becomes true. Clear? If nothing, no swap is happened, now what I will do is like, if not swap, if I didn't swap anything, so in the first iteration itself I can know that the array is already sorted, I will break it. Clear? This is the second optimization. So for if array, this is for if array is sorted, and that is also for the best complexity order of n. Clear? That's it for this video, guys. Thank you.